Welcome to the final chapter of this course, Processing Data. Scikit-Learn requirements. Recall that Scikit-Learn requires numeric data with no missing values. All the data that we have used so far has been in this format. However, with real-world data, this will rarely be the case. And instead, we need to process our data before we can build models. Deal with categorical features. Say, we have a data set containing categorical features such as color. As these are not numeric, Scikit-Learn will not accept them and we need to convert them into numeric features. We achieve this by splitting the feature into multiple binary features called dummy variables. One for each category. 0 means the observation was not that category, while 1 means it was. Dummy variables. Say we are working with a new music data set that has a genre feature with 10 values such as electronic, hip hop, and rock. We create binary features for each genre. As song has one genre, each row will have a 1 in one of the 10 columns and 0 in the reset. If a song is not any of the first 9 genre, then implicitly it is a rock song. That means we only need 9 features so we can delete the rock column. If we do not do this, we are duplicating information, which might be an issue for some models. Dealing with the categorical feature in Python, to create dummy variables, we can use the scikit-learn one-hot encoder or pandas get underscore dummies. We will use the get underscore dummies music data set. We will be working with a music data set in this chapter for both classification and regression problems. Initially, we will build a regression model using all features in the data set to predict song popularity. There is one categorical feature, genre, with 10 possible values. So here, the box plot shows how popularity varies by genre. Let's encode this feature using dummy variables. We import pandas, read in the data frame, and call the pd.getDummies, pass the categorical column. We only need to keep 9 out of our 10 binary features. The first song is George and the second is rap, indicating by a 1 in the respective columns. To bring these binary features back into our original data frame, we can use bd.concat, passing a list containing the music data frame and our dummies data frame, and setting access equal to 1. Lastly, we can remove the original gender column using df.drag, pass in the column, and set in access equal to 1. So, encoding dummy variables. If the data frame only has one categorical feature, we can pass the entire data frame, thus skipping the step of combining variables. If we don't specify the column, the new data frame's binary columns will have the original feature name prefixed. So they will start with gender underscore hyphen underscore as shown here. Notice the original gender column is automatically dropped. Once we have dummy variables, we can fit model as before. So linear regression with dummy variables using the music underscore dummies data frame. The process of creating training and test set remains unchanged. To perform cross-validation, we then create a k-fold object, initiate a linear regression model, and call cross underscore val underscore score. We set scoring equal to neg underscore mean underscore squared underscore error, which returns the negative MSE. This is because sklearn's cross-validation metrics presume a high score is better. So MSE is changed to negative to contract this. We can calculate the training RMSE by taking the square root and converting into positive, achieved by calling numpy.square root and passing our scores with a minus sign in format. Let's practice working with the categorical feature. So as you see that we have the data set, that is music gender. So this is the data set. So it contains the one column music underscore gender. There is few fields. There is a 10 different type of genres here. These are 10 different type of genres here. And okay, so then we so we are create. I imported the pandas, numpy, and matplotlib. Import the music data, and so we imported the panda, then clean data, then imported the music data. We then we converted to categorical data into dummy variables. Then we are contacting that, combining both the original data. So this is the values after dummy variables, converting dummy variables. Then this is the new columns. So yeah, this is the mean squared error. So this is the mean squared error. Then when we average of that for this, so this is the average and standard deviation. So compared to standard deviation, average is good. So this model is good. Yeah, like this we are converting to this is the example of get dummies. Yeah, I'm stopping here. We'll connect to another session. Thank you.